National Electrical Code, or NEC, Article 110.3b states that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. This is a fundamental requirement ensuring that equipment is installed as the manufacturer intended. NEC Article 250.12b addresses making and maintaining connections, specifying that they shall be in accordance with the requirements of the NEC and any additional requirements of the equipment manufacturer. This article emphasizes the importance of following both general NEC guidelines and specific manufacturer instructions for all electrical connections. NEC Article 312.3b pertains to terminals for conductors larger than number 10 American wire gauge or AUG, stating that these terminals shall be of a type approved for the conductor or cable used. This ensures that the terminals are compatible with the conductors, preventing potential issues like overheating or loose connections. NEC Article 364.2e discusses equipment grounding conductors, specifying that they shall be spliced or connected by means of a listed splice or connector. Using listed components ensures that the grounding connections are reliable and safe. NFPA 70 Standard for Electrical Safety in the Workplace, Section 130.7 directly addresses the use of torque wrenches. It states that where torquing of bolts or screws is specified by the manufacturer's instructions or by the requirements of the applicable code, such torque shall be applied using a properly calibrated torque wrench. This requirement makes it clear that if a specific torque is required, a calibrated torque wrench must be used. These code requirements indirectly support the use of torque wrenches by referencing the manufacturer's instructions, which typically specify torque values and methods for proper installation. The NEC frequently refers to manufacturers' instructions for proper installation procedures. These instructions often include specific torque requirements for bolted connections, terminals, and other components. The reason torque specifications are important boils down to ensuring reliable and safe electrical connections. Over-torquing can damage the equipment, strip threads, or weaken the connection. Under-torquing can lead to loose connections, which increase resistance, generate heat, and potentially cause fires. A properly torqued connection ensures optimal electrical contact and mechanical stability, reducing the risk of failures. The use of a calibrated torque wrench ensures that the correct amount of torque is applied to a connection. Calibration is essential to ensure that the wrench is providing accurate readings. Regular calibration ensures that the tool meets the required accuracy standards, typically plus or minus 4% of the specified torque value. If a torque wrench is not calibrated, there is no guarantee that the applied torque matches the manufacturer's specification. This can lead to the same problems associated with over or under torquing. Electrical equipment manufacturers often provide detailed torque specifications for their product. These specifications are based on extensive testing and are designed to ensure the equipment operates safely and reliably. Ignoring these specifications can void warranties and increase the risk of equipment failure. When reviewing manufacturers' instructions, pay close attention to the specified torque values. These values are typically provided in units such as count inches, pound-feet, or Newton meters. Ensure that the torque wrench is set to the correct unit and value before tightening the connection. Torque wrenches come in various types, including click-type, beam-type, and electronic torque wrenches. Click-type torque wrenches are the most common, providing an audible click when the set torque value is reached. Beam-type torque wrenches use a pointer to indicate the applied torque on a scale. Electronic torque wrenches provide a digital readout of the torque value and often include features such as data logging and programmable settings. Choosing the right type of torque wrench depends on the specific application and the level of accuracy required. For critical connections, an electronic torque wrench with a higher accuracy rating may be preferred. The NEC doesn't always explicitly state that a torque wrench is required, but the combination of articles referencing manufacturer's instructions and the emphasis on proper connections implies its necessity. For example, when installing a circuit breaker, the manufacturer's instructions will likely specify a torque value for the terminal connections. Following NEC Article 110.3b, these instructions must be followed, necessitating the use of a torque wrench. Similarly, when granting equipment, NEC Article 250.12b requires that connections be made according to the manufacturer's instructions, which often include torque specifications. In situations where conductors larger than number 10 AWG are being terminated, NEC Article 312.3b requires approved terminals, and the manufacturer's instructions for these terminals will likely include torque values. Grounding conductors, as covered in NEC Article 364.2e, must be connected using listed splices or connectors, and the manufacturer's instructions for these components will also likely include torque specifications. In addition to the NEC, NFPA 70E provides further guidance on electrical safety in the workplace. Section 130.7 specifically addresses the use of torque wrenches when specified by the manufacturer or the applicable code. This standard reinforces the importance of using calibrated torque wrenches to ensure safe and reliable electrical connections. The process of torquing bolts and screws involves several steps to ensure accuracy and safety. Firstly, identify the correct torque value from the manufacturer's instructions or relevant documentation. Secondly, select the appropriate torque wrench and ensure it is properly calibrated. Thirdly, adjust the torque wrench to the specified torque value. Fourthly, position the wrench in the bolt or screw and apply steady pressure until the wrench clicks or the desired torque value is reached. Fifthly, avoid over-torquing by stopping immediately when the wrench indicates the correct torque has been applied. Regularly inspecting and maintaining torque wrenches is crucial for ensuring their accuracy and longevity. Check for any signs of damage, such as cracks or worn components. Clean the wrench after each use and store it in a safe place to prevent damage. Periodically calibrate the wrench to ensure it continues to provide accurate readings. The frequency of calibration depends on the usage and the manufacturer's recommendations. Calibration services are available from specialized companies that use precision equipment to verify and adjust the wrench's accuracy. Implementing a torque program within an electrical contracting company can help ensure consistent and reliable connections. This program should include procedures for identifying torque requirements, selecting and calibrating torque wrenches, training personnel on proper torquing techniques, and documenting torquing activities. Documenting torquing activities provides a record of the work performed and can be useful for troubleshooting and quality control purposes. This documentation should include the date, location, equipment, torque value, and the person who performed the torquing. Using a torque wrench is not just about meeting code requirements, it's about ensuring the safety and reliability of electrical systems. Proper torquing reduces the risk of loose connections, overheating, and electrical failures, protecting both equipment and personnel. Investing in torque wrenches and training personnel on their proper use is a worthwhile investment that can save time, money, and potentially lives in the long run. Ignoring torque specifications can lead to a variety of problems, including equipment damage, increased maintenance costs, and safety hazards. Loose connections can cause arcing, which can damage equipment and create a fire hazard. Over-tightened connections can damage threads and weaken the connection, leading to premature failure. By following manufacturer's instructions and using calibrated torque wrenches, these problems can be avoided. When selecting torque wrenches, consider the range of torque values required for the types of equipment being installed. It may be necessary to have multiple torque wrenches to cover the full range of torque specifications. Also, consider the environment in which the torque wrench will be used. For example, in tight spaces, a compact torque wrench may be required. In harsh environments, a durable torque wrench with a protective coating may be necessary. Training is a critical component of any torque program. Personnel should be trained on how to properly use torque wrenches, how to interpret torque specifications, and how to identify potential problems. This training should include hands-on practice and should be regularly updated to reflect changes in codes and standards. In addition to torque wrenches, other tools and equipment may be required to ensure proper connections. These may include wire strippers, crimpers, and measuring tools. Using the right tools for the job can help ensure that connections are made correctly and efficiently. When working with electrical equipment, always follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. De-energize equipment before working on it whenever possible. Follow lockout/tagout procedures to prevent accidental re-energization. The NEC and NFPA 70E provide a framework for ensuring electrical safety in the workplace. By understanding and following these codes and standards, electrical contractors can create a safer working environment and ensure the reliability of electrical systems. Using torque wrenches is an essential part of this process. It demonstrates a commitment to quality and safety and helps to prevent costly and dangerous electrical failures. In conclusion, the NEC, specifically Articles 110.3b, 250.12b, 312.3b, and 364.2e, along with NFPA 70 Section 130.7a, indirectly and directly support the use of torque wrenches in electrical installations. These codes emphasize the importance of following manufacturer's instructions, which often include specific torque requirements for bolted connections and terminals. Using a calibrated torque wrench ensures that the correct amount of torque is applied, reducing the risk of loose connections, overheating, and electrical failures. Investing in torque wrenches and training personnel on their proper use is a worthwhile investment that can save time, money, and potentially lives in the long run.